All right, this is now the 6th time, pronunciation is key, recording this. My life is hell. I even wrote down a little guide here.
From the black boughs of abomination it grows. 30 days sweep the milk of pestilence. Apostle Antichrist, bearer of the inverted cross. Eyes clouded with the cataracts of the end. Exploit the void beneath the moon and feast on stillborn limbs. Tail coiled like the serpent.
Round 7. I figured out I can hold it up backwards. Look at that. We're going to follow these guidelines. I'm starting to get pretty angry. I've wasted about an hour. User packet. Let's go. So, around January 8th, we've sent out this user information packet that explains the BloomCon CTF. These videos are going to be post-conference. They're going to go over a little bit of the methodology behind how it was set up. Obviously the solutions, and yeah, just general gee whiz information that when my ADHD kicks in, we'll explore. So, yeah, background information. If you didn't participate, this facility, MNCC, was victim to a supply chain attack from a malicious container that had a C2 agent in it that called back to some bad guys over in this area, utilizing their version of Linux called Astra Linux. This host had a Sliver C2 service that the Grafana instance within the compute node stack was calling out to. From there, they were able to horizontally move through the environment, gaining access to admin and login nodes, and kick everyone out. It was our job to break back into the cluster. We weren't provided any usernames or passwords, but we had to find a way. Hopefully all of my browser stuff is still working. That is fantastic. Let's make me smaller so I can see myself. Great. Look at that. I can look at the web browser. Fun. Diving right in. Access. The first two tasks within the BloomCon CTF were not meant to be challenging. They were there to verify that you were able to access the infrastructure via IP address or the DNS names provided above here, right? Once you access that dashboard for the first initial question, you were provided a encoded string. Now this encoded string had a little bit of a curveball here, right? So if you first saw that string and assumed base 64, you were wrong. Curveball. It was base 32. Base is spelled with an E. That's pretty slick, right? If you didn't figure that out, if you were to copy that encoded string and go to GCQ, or I told you I did this multiple times, it's already there. It's staged. I planned it. And take the magic and then add it to this encoded string. This means that CyberChef will attempt to understand what this encoded string is, and then using entropy verify what type of encoding it used. So it found that it was base 32, and we have found the flag called I'm based. If you were to enter that into CTFD, hopefully, Lunar, possibly get some points. I don't know if we've decided if this was a point-based flag or not yet. As you can see, it's January 16th. Moving on. The other web interface for the BloomCon CTF was Etherchimp. Etherchimp was designed for this competition. It's a live packet network forensics tool. It can provide things like TCP streams. You can see traffic for Slurm here. If you don't want to look at Slurm traffic, you could just go back to all protocols and cycle through here. What was that red one? Is there anything other than Slurm going on in this cluster? Green. I saw some green. I see some unknown. 8086. So that is the Slurm database. Fun stuff, right? If you gained access to this EtherChimp interface and read further, you could see some bolded text, authenticating in plain text. That was supposed to guide you into like utilizing the search bar within this tool here to search for passwords. Instead of just manually going through this entire string of packet data here, you can come up here and type password. You'll see that a password txt was queried at one point. Now this is on a cron. It fluctuates between 1 and 10 minutes. So if we give the system some time to figure out what's going on, I actually know a username, but I want to see if, good, passwords. We can see that the curl request happened at 10:57. It is now 10:58. So that happened pretty recently. If you go down below here, you can see that the Keycloak database, which is what this guy uses for authentication, you can see that if you see realms here, this is a Keycloak identifier, point blank simple. If you didn't know that it was Keycloak, and we went all the way back here, you could delete this part and see that it is Keycloak. Fun. ADHD. Next, let's choose a random person. Let's do Daniel Harris. Hopefully I could spell his name correctly. Daniel Harris. When you first log into the Keycloak instance, it's going to prompt you to reset your password. Definitely reset your password. Resetting your password means that other competitors can't squat on your user or watch what your user is doing. So if you found a flag and it was in your Daniel Harris home directory, other people would, see it if they logged in as that user. So if we go ahead and pretend change our password here, we can get a bad request because I've logged in as too many people for the 7th time in a row. We'll see Open On Demand populate. We're greeted with a little bulletin board here and some announcements. They're basically reiterating everything that I just said about, the security incident that occurred. Open On Demand provides a lot of features as you were able to explore this kind of like functionality. Hopefully people caught that you can get some fun stuff to trigger within Open On Demand with JSON. Maybe we'll explore that in a separate video, but the Ruby or backend interpreter of this actual change directory function will attempt to read JSON files. So this file doesn't exist, but it will attempt to read that file. And if it reads that file, you can possibly launch serialized JSON strings, which would give you access to the Podman container. And if you gained access to there, you could pretty much beat the game quickly, except for the Astra stuff, now that I'm thinking about it, or the Slurm stuff. So, yeah. Next slide. My first job. Before the competition started, right, we gave you this packet of information. We told you to study a bunch of stuff. One of those main things was Slurm. We're going to focus on Slurm and Apptainer in this video. Hidden repos 1 and 2 kind of focus on understanding how Apptainer works. You were able to find this flag in 2 ways. So let's go to clusters, container node. So the container node provides direct access to the cluster, right? You can get PTY sessions within that environment, whereas on the bare metal login node, if you were to clear this, srun pty, I already know that MPI is not loaded on this node, so we can't utilize that functionality. And bash, you'll get an error. So if you utilize something like ChatGPT or Google AI, and it told you to run this command to get access to a node, it wouldn't work here, but if you tried here, it would work. Right, so every flag within this, my first job, kind of followed this flag syntax. So if you're looking for something called like flag.text, you can use a simple find command, basic Linux, to find flag.text to out of null. I think I need an and there. Nope. And if you were to cat that flag, cat temp flag, you would find the first real flag, right? The other one didn't really count. If we hop to the bare metal node, you could do the same functionality that you can on the container node, but you need to use sbatch. And when you use sbatch, you need to kind of direct Slurm where to put your jobs a little bit more directly. So we're going to say we need one process, we need one node. We're going to wrap our srun command in find name flag.text. Now, not every node in the cluster outlined their flag as flag.text, but we'll see if we hit a node that did. It looks like we did. It was an opt. I have no clue what node that ran on. I could look at my job queue, right? We could see probably ran on node 3. So let's go ahead and call that node W node 03. And we're just going to cat and hope that that was the node that has that flag. Cat slurm 4. It was! Fun. If you didn't know that, there is an sjob command. I don't know that off the top of my head, so you're going to see me Google search. Sjob show where recent jobs have run slurm. I don't use slurm often enough. SQ me. Let's control show job. (19564) 19564. Looks like we launched on node 3. That was the wrong job. This is the job we called node 3 on. But if we were to backtrack this, we could go back to this job number, click that, come back down here, paste that, call it a day, and say, hey, I ran my job on node 3, right? I need to memorize these commands. Actually, I'm pretty sure if you had this instance. No, it doesn't. Nice. Exit. Bam, 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 bam. Get rid of you. I'm not re-recording this, so I'm sorry you had to watch me Google search there. We're not all perfect people. Hopefully I'm recording. Hopefully there's audio. Oh, that would be terrible. Next slide, hidden RPMs. This directly revolves around Apptainer. It's the container of choice for this HPC environment. If you were to Google HPC's favorite container solution. First thing that comes up is Apptainer, right? So that's kind of everywhere. This competition was based off a lot of Google searches and getting information from Google AI. So if I typed in HPC's favorite front end for scheduling jobs web service, that's just Slurm Workload Manager. There's a Slurm Web. But as you can see here, open on demand, right? So we based a lot of this competition on like Duke, LLNL, anything that I could kind of get public information on via the internet. And that's ADHD kicking in again. So you get to see that in real time. Right. Keeping on track. Go to repos 2. So we have to do repos 1 first. The APT must play a lot of CTFs to put flags everywhere. Seems like they are distracting us from their supply chain and repository poisoning efforts. The hackers have populated malicious files within the repo server. So if you see RPM and repo server, you're most likely dealing with DNF and Yum package management. You can figure that out pretty fast just by accessing the login node and catting etcos release and figuring out that, hey, I'm using Rocky Linux. And if you type in Rocky Linux packet RPM package manager, let's do package manager. DNF, DNFied Yum. We're all learning things today. Clear. If you were to Google search how to query DNF for package flag. I don't know if Google's going to understand that. This could be a botched operation. Repo query installed, list installed provides, this is all installed. What we're looking for is search. Google will tell you to DNF search something, DNF search firewall D. So we could see that CTF and flag are bolded out. If we were to DNF search flag, we should error out. Users within this login node are not able to query the repos of the environment. You can't read them. So if you try to utilize something like DNF, you should get permission denieds, right? How do we work our way around that? At the bottom here, we elicited that definitely not manipulated containers under the C directory. C is a callback to Windows. If we LA, the C directory, you can see that we have the home directory, which is us, and we have containers, which have images and definition files. Clear. Now, this was a very important part of the competition in the beginning. If you go to C, containers, images, you'll see a little note file, right? Read the note file, read the README file. They're there to help you out. I don't know why I'm saying that now because this is post-competition. So, important disclaimer regarding shared containers. This notice serves to inform all users regarding the shared container library located at C containers images. Basically, it's saying inspect the containers, right? If you were to copy paste this in ChatGPT, it would allude to a command called apptainer sif dump, or let's do list first, which will give you information on the container. It's metadata, right? Apptainer containers are built with something called a def file, which you can see right here, and the rootfs of that container can be found at the bottom. This little squash fs image represents a Linux system like you would find here. So if we were to log into this container and run this command, it will look somewhat like this, but it will not exactly be this. So apptainer sif dump 1 mncc sif. Now previously we tried to cat all of those local repos for the HPC environment, but here we could see that this provisioned mncc container is giving you those freedoms, right? So that you can utilize the local resources within the environment. It's deleting everything in Rocky. It's installing wget curl nmap and ncat, or I mean just netcat, not the full nmap suite. It's cleaning all. It's giving you some delightful information here, and manipulating your prompt session variable. If we log into that container, apptainer shell mncc.sif, you can see we're us, right? lsla. If we do here, we can actually see that we have readable access to those directories. But if we attempt to install something like, let's say, nmap, we'll get some permission denieds and failures. Clear. Within this guide, we outlined up here on the research side, fake root. This is something you need to heavily utilize for this competition. We're going to apptainer shell f for fake root. Actually, I'll type it out. Fake root. Look at that. Typing is fun. Writable tempfs. We need this writable tempfs flag because apptainer containers are inherently immutable, meaning they're a read-only file system. So if you attempted to do something like DNF install a new package, it wouldn't be able to write to that specific path within the container unless you had a writable tempfs overlaid over top of it or populated via the squashfs image. We'll do mncc sif, enter. Now you can see that I'm root, right? This isn't the true root of the system. This would be akin to if you were to launch a Docker or Podman container in user space and log into that container as root. It's not the same thing. Your privilege level hasn't escalated at all while you're inside this environment. We'll also notice that if I print my working directory, you can see that I've CD'd to home here. I'm now in root, but all of my files are still here. Apptainer always bind mounts the home directory of the user. So if I'm in my home directory and touch hello, you'll see hello is in there. And if I do apptainer shell f for fake root, not typing it out, right, double tempfs c home containers images and mncc, you'll also see that hello is there, and you can take files outside of the container and put it into that home directory, which will be useful, right? Data movement. You don't want to set up things within this container, exit it, the tempfs image stored in RAM gets deleted, and then now you don't have access to your stuff anymore. So let's go ahead and do something simple. DNF sectf. SE is short for search. Right now it's querying the local repositories, and it's providing us with 3 different challenges. These challenges correlate to the hidden RPM challenges. Each challenge kind of teaches something different. The first 2 are, if you figure out hidden repos 1, you'll figure out the second one quite easy, but really I wanted you to get familiar with the DNF command. So if we do DNF info CTF flag easy, typing is fun, you could see that, hey, we're going to install flag into temp/flag.txt, temp/flag.txt. I have to get comfortable with, actually, you know what, DNF install clear. Actually, what provides clear? AD provides clear, ADHD, probably something core utils. No? ncurses, DNF and ncurses. Install that so we can do this command. Fun! Clear. Look at that. Look at that. Clear. Nice. 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 Fun. Cat temp.flag. We didn't install it, so DNF install CTF flag easy. Great. Now we don't have to do a find command. We know that it is in flag.txt. So we can cat that. You can see DNF is better than APT. personal preference. But if we move on to the next flag, if we control R and then type provides, right? Actually, we type info and go all the way to the end here and change this to medium, you'll see that this new flag installs to root. But we also know that our home is root, pwd. If we DNF install, actually we'll make it quiet, CTF flag medium, we can cat root flag and see another one. But the cool thing is that flag is right here as well. And I'm so sorry I don't have a microphone. I know the keyboard typing thing is very annoying, but yeah. Nice. Looking at my guide here. Yeah, user packet, go to repos to, and don't fuck up. I think we nailed that. I really hope I don't have to record this. But thank you for watching the initial video. I'd say if you have any questions, please, ask me. But you can't, except for comment sections. I don't know if this account's going to be active by me when this competition's over, but the next video will follow Hidden Repos 3. Why do I call them hidden repos? They're hidden RPMs. Where a container is going to install inside a container. And you're going to have to move that container image to a bind-mounted directory like home. And then we'll find that that container has some special sauce in it that we have to break, decrypt, use hashcat or shell scripting to figure out. So thank you for watching the video. Bye.